In Unit 1, we talked about how to solve a one-step equation, and now we are going to move on to solving multi-step equations. But before we do that, let's go ahead and just review solving one-step equations. So remember that when we're solving an equation in general, our goal is to get the variable by itself, right? And so I always start by putting in my balance line that goes right through that equal sign. And I do that just so I could visually see that I'm doing the same thing to both sides. So in number 1, my goal is to get h by itself, so I'll go ahead and add 12 to both sides, and that cancels out that minus 12, so h is now by itself, and h is equal to, let's see, that would be 39. Then in number 2, so this one's tricky because, well, mostly because it's a fraction that usually stumps us. So think about, well, what operation do we see? And that's division. So what I would do is I would multiply both sides by 7. Multiply by 7, multiply by 7. So what happens is that divide by 7 cancels. And so I just have b is equal to, and then negative 56. So moving on to multi-step equations, I always kind of say we do the opposite of order of operations. So we always want to undo addition and subtraction first, as long as we don't see any parentheses, and then we'll undo multiplication and division, and then maybe any exponents, but that's not for a couple units. So in number 1, I see addition, so I would start by undoing that first. So I subtract 7 to both sides, and this cancels. I'm left with 3x is equal to 12. And then finally, in between the 3 and the x is the operation multiplication. So I'll simply divide both sides by 3, and then x is equal to 4. In number 2, what makes this a multi-step is that I can make this a more, what's the word I'm looking for, like a condensed equation. I can simplify this, meaning I can combine like terms. So I've got 4a plus 3a, and that is 7a. So I get 7a is equal to 63. And then I'll divide both sides by 7, and a is equal to 9. Now, number 3, what makes this different is I have a set of parentheses. So I have to simplify that first, kind of like combining like terms in a way. So what I would do first is I would distribute the 2 to everything. So 2 times 10 is 20. 2 times 4k is 8k. And then I bring down the rest of the problem. And then just like in number 2, I can combine like terms. They kind of share the same last name is what I'll say. So 8k plus 2k is 10k. So I'll rewrite the problem with 10k. And now you may not like the equation looking like that. So maybe what you want to do is rewrite it as 20 plus 10k is equal to 40. That way your variable is on the left-hand side. And then I'll go ahead and subtract 20 to both sides. And my 20s cancel. I'm left with 10k is equal to 40 minus 20 is 20. I apologize, I kind of ran out of room here. And then I would divide both sides by 10, and I get a value of 2. So in numbers 4 and 5, I wanted to specifically make sure that I included some fractions. A lot of times fractions scare us. Don't let it scare you. It works the same as whole numbers. So in number 4, again, I see a set of parentheses. So that tells me I need to distribute first, right? So I'll distribute the 1/3. Now, really quick, here's how you do this in your head. So I've got 1/3 times 6. So rather than taking out your calculator and wasting a few more seconds on typing all of this in correctly, what you'll do is you'll just do 6 times 1, which is 6. 6 divided by 3 is 2. So that was a lot easier, right? So then I get 2x. Okay, let's do it again, but this time with distributing it to 9. So 1/3 times 9. So I do 9 times 1, which is 9. 9 divided by 3, which is 3. So I get minus 3 plus 12 equals 19. So beautiful, that worked out really nicely. And now I have all whole numbers. I'll go ahead and combine like terms that I have right here. So that's 2x, and then negative 3 plus 12 is 9 equals 19. Put my balance line in. I'll subtract 9 to both sides. So I get 2x is equal to 10. And I kind of ran out of room here, so let me just rewrite that. 2x is equal to 10, because now I'll go ahead and divide both sides by 2, and I get that x is equal to 5. And I'll circle that. So let's try same concept with the fractions, but in number 5. And I'm going to go ahead and erase my answers that I have for 3, just so I have some space here. It's kind of a lot going on, so hopefully you have that written down. So in number 5, I'll distribute the 4/5. So again, in my head, here's what I'm doing. I've got 4/5 times 10. So I'm doing 10 times 4, which is 40. 40 divided by 5 is 8. So I have 8x. So now I'll do 4/5 times -5. Well, I know a positive times a negative will be a negative. So in my head, so I'm doing 4/5 times 5. So 5 times 4 is 20. 20 divided by 5 is 4. So I get 4 here, and then I'll bring down the rest of my problem. And then I have like terms, so 8x and -3x, which gives me 5x minus 4 is equal to 21. And then I'll go ahead and put in my balance line, and I'll add 4 to both sides. So I get 5x is equal to 25, and I'll divide by 5, and x is also equal to 5. So why don't you guys try number 6 and 7 on your own? So in number 6, hopefully the first part didn't fool you, and I'm going to go ahead and erase number 4's work because it's kind of in my way. So you should have distributed only the -3 because that's what's next to the parentheses. So I would have 4 minus 6x minus 6 is equal to 12. And then I would combine like terms. So I've got 4 and -6, which would give me -2. So I would rewrite this as -6x minus 2. Hopefully I didn't drop the negative. And then I would add 2 to both sides. And I get -6x is equal to 14. So if you're kind of like already one step ahead and thinking, okay, well, I know 14 isn't divisible by 6. I feel like sometimes the minute we get a decimal, we think we've done something wrong, but don't worry, you haven't. You should have then divided by -6, and maybe you kept it as a fraction, so maybe -7/3, or that's -2.3 repeating. So it is possible to get a decimal, and that doesn't mean you did it wrong. And then in number 7, you would have, let me just kind of break this up here, distributed the 4, and you would have had 4x minus 16 plus 3x is equal to -16. And then combine like terms, so we get 7x, and then we'll bring down the -16 is equal to -16. And then now I'm going to try and get a variable by itself, so I put in my balance line and I add 16 to both sides. And I get 7x is equal to 0. So a lot of times when students get to this part, we think that x is 7, but that's not true. I want to divide both sides by 7, and we get that x is actually equal to 0, which is a solution. So why don't you, now that you've seen those options as well, why don't you try number 8 and 9 on your own as well? So in number 8, you should have distributed the -3. So watch your signs. That would have given you -12x plus 30 plus 2x is equal to 60. We would combine like terms. So -12 plus 2 would give me -10x plus 30 is equal to 60. Then go ahead and draw my balance line and subtract 30 to both sides. And I would get -10x is equal to 30. And divide by -10, and x equals -3. Hopefully you didn't drop any negatives in that one. And then in number 9, we'll distribute the 1/2. So I know 1/2 of 8 is 4, so 4x. 1/2 of 14 is 7, equals 51. Draw my balance line and subtract 7 to both sides. So this cancels. I'm left with 4x is equal to, let's see, that'd be 34. Yep. And then I will divide both sides by 4, so dividing by 4. And 34 divided by 4 is 8.5.